All right, guys, we're back. We just finished up our last unit, which the last unit was on, let's see, what was the actual title called? It was the angles and lines unit. We just finished that one up. Everybody at this point should be either started or done with their unit tests and stuff like that. If you haven't checked it out, go check out our new Google Classroom. There's the little TV inside of it that shows where it's at. You could find that in the Google Classroom. With that right there being said, I'm going to start using that TV for the latest video. So I'm going to change the video today for this one. This one will be the new video coming up. So you'll click on that. It'll take you to YouTube. I did do that. So that way you guys could have access to that. It's a private channel that you guys will have all the videos to and everything like that. If you subscribe, I guess, or I'm not too sure. All you really got to do is go to the Google Classroom and click on the CDs or the DVDs and or the TV. That'll show you the latest unit and everything like that. So what I'm going to do is we're starting our new one. I'm going to go ahead and share my screen. Okay, so now we're on to our next unit, which starts today, which is unit triangles. So all we're going to be working with now is triangles. I'm going to go ahead and, as always, I'm going to do my guided notes. I'm going to pull those up, and I'm going to do the instruction and warm up. So let's download the guided notes. Okay. I'm downloading those, but I always put them inside of my guided notes folder, and we're right here. Okay, so let's see. So now come to my computer here. And look for my triangles, angle theorems. Okay, you can see it's rotating there. So I'm gonna go ahead and clear this one off, and we're gonna get ready to start working with this. Okay, so this says that we're here. What happened? Okay, there it goes. Working a little slow today, I guess. So let's go ahead and get started with the warm-up. Come on, Dochub.
What happens if we take the triangle and break it apart? We pull off the top, and the two bottom angles we rip apart. Now we're going to realign them. So we're going to bring the top angle down, and notice that the three angles form what? They form a straight line. So this tells us that the interior angles of a triangle sum up to 180 degrees. Let's see if we can prove this mathematically. We'll be answering the question, how are the interior and exterior angles of a triangle related?
Okay, so how are exterior angles of a triangle related? Okay, so I'm gonna go ahead and put the right there like that, and here, move that up a little bit. Okay, so let's go on to the next one.
Our lesson goals are to analyze relationships between interior and exterior angles of a triangle. And how will we do this? We'll prove that the sum of the measures of the interior angles of a triangle is 180 degrees. We'll identify interior and exterior angles of a triangle, and we'll calculate the measures of interior and exterior angles of a triangle. Let's look at some key words that you need to know. We have exterior angle, interior angles, remote interior angles, and supplementary angles.
I'm gonna pause that right there and back that up to that last part right there, because we're, as always, we got to make sure that we do our definitions. Okay, let me just figure this. Calculate the measures of interior and exterior angles of a triangle. Okay, now let's go scroll down a little bit. Now I already know these ones, but there's a glossary for all those ones if you need to. Okay, so the exterior angle is the angle formed by the side of a figure. Okay, so that's gonna be D. Oh, why did it scroll like that all crazy? Sorry. This one is D. Okay, the interior angles, those are the angles formed by each pair of adjacent. Is that, yeah, that's going to be interior angles is A. And remote interior angles are the two angles whose measures have a sum. No, that's not it, because that's supplementary. This is C, because the supplementary angles are two angles that measure to have a sum of 180 degrees, and the remote angles are going to be the two non-adjacent interior angles corresponding to the exterior angle of a triangle. We'll get into more of what that means here in a little bit, but basically their triangle has 3 sides. So if we're working with the opposite 2 of the angle that we're looking for on the outside, the exterior angle. All right, so let's go ahead and get back into this. Go back to the activity and hit play.
What are the angle pair relationships that are actually created by parallel lines P and Q that are cut by a transversal, in this case line S? Well, for example, we have corresponding angles. Angle 1 is congruent to angle 5. Angle 2 is congruent to angle 6. Angle 3 is congruent to angle 7. And angle 4 is congruent to angle 8. We also have alternate interior angles. These are angles that are on opposite sides of the transversal. Angle 4 is congruent to angle 6.
Alternating
and
interior.
Angle 3 is congruent to angle 5.
Alternate interior, opposite
Lastly,
side of the
we have
line.
same side interior angles. So these are angles that are supplementary. For example, same side of the transversal. Angle 4 and angle 5, these angles will sum up to 180, as will angles 3 and 6. There will also exist vertical angles, alternate exterior angles, and other relationships that are formed when 2 parallel lines are cut by a transversal. Use the diagram of parallel lines G and H cut by transversal F to answer the questions.
All right, before I do this, I'm going to come over here and corresponding angles. Corresponding angles are 1 and 5. Remember, they got to correspond to the same side. If this right here was all alone compared to this one, this angle 1 and 5 would be the same. 2 and 6 would be the same. 4 and 8 would be the same. 3 and 7 would be the same. So this is going to be the same thing as angle 7, but I don't have an angle thing, so I'm going to draw that, and I'm just going to go like this. Angle 3 and angle 7 are corresponding. We have angle, I'm going to do this one like this with my angles, so that way we know what they are. And this is the same thing as that. It should have the little marks like that. Okay, not very good drawer, but nonetheless, you guys see what I'm saying. And this is angle 4. Angle 4 is equal to angle 8. Okay, alternate interior angles 4 and 6, also 3 and 5. So this is angle 5. Okay, supplementary angles are the 2 angles on the inside on the same side of the transversal that will add up and equal to 180 degrees. 4 and 5 are on the same side, so those 2 are supplementary. 3 and 6 are also supplementary. So angle 3 and angle 6. Okay, I was gonna say, where'd it go? All right, so now we're over here. Use the diagram of line G, which is parallel to the line H, with the transversal of F to answer the questions. Okay, a pair of corresponding angles in here corresponding are going to be these 2 right here. 4 and 5 are corresponding. 1 and 8 are corresponding. 3 and 6, again, this and this. Wherever these two are, these two are, and those 2 are. Okay, if you don't understand what they are, you could just look and compare these ones. Angle 1 and 5, angle 1 and 5. So we can go angle 1 and 5 on this one are also corresponding. Okay, we don't have angle 1 and 5, but 1 and 3, those are vertical angles. 4 and 2, also vertical angles. 4 and 8 are the only corresponding angles, so it's that one. Angle 2 and angle 8, well, these ones are on alternate interior, because this is angle 4 and 6, 3 and 5, so this one's asking 2 and 8. Those 2 are, let's see, congruent. Angle 2 is congruent to angle 8. Okay, so let's see it, because alternate angles are congruent. 4 and 6 is congruent, so that's going to be congruent to. And a pair of the same side interior angles is same side interior angles 2 and 5, 3 and 8. So it's going to be 2 and 5.
Let's see how parallel lines can help us uncover an important property of triangles.
Now we're on to the instruction.
We've been answering the question, how are the interior and exterior angles of a triangle related? And we've studied special angle relationships formed when 2 parallel lines are cut by a transversal. We're going to use these relationships to prove special relationships about the interior angles of a triangle. Recall, interior angles are angles that are formed inside of a figure by adjacent sides of a polygon. Consider the interior angles of any triangle. How can we go ahead and actually prove that the sum of the measures of the angles in the triangle is 180 degrees? Well, actually, we use Euclidean geometry. We start by sketching two parallel lines. One line is actually an extension of the side of a triangle, and we sketch through a vertex another parallel line. We cut those parallel lines with a transversal, and we recognize and remember that alternate interior angles are congruent. And we use this information to help us prove that the sum of the interior angles of a triangle are 180 degrees.
Alternate interior angles are congruent, and they add up to equal 180 degrees. Okay.
Use the given diagram and information to prove that the sum of the measures of the interior angles of a triangle equals 180 degrees.
Okay, these are always fun, aren't they? Okay, so the first thing, given y is equal to z. So statements, let's see where they are, lines and angles. So we're given that y is parallel to z, which y is parallel to z. And the reason is this is given. Okay. Okay. So now we are proving that measurement of angle 5 plus the measurement of angle 2 plus 6 is equal to 180. So that's our last statement. That's what we're going to be proving there. Okay. So let's see what we have. We have it's going to throw us right into these ones. So now we know that the measurement of angle 1 where is the not the measurement of angle 1. Well, the measurement of angle 1 is congruent to the measurement of angle 5. Let's see if this is going to be the right statement. Because of alternate interior angles. Okay. Okay, so that's not part of it. So let's see, the diagram shows parallel lines cut by a transversal. Okay, so these two there, so we know that the measurements of angles 2, 5, and 6, 2, 5, and 6 are equal to this, and this is because of the alternate interior. That's the alternate interior angles theorem. That's the sum. I don't think we're here yet. We have to be. So we're trying to prove that angles, these ones, are equal to angle 180. So I thought that that would mean that angle. Let's see if it's this one has to do with it. Okay, So what I said here is the measurement of angle 1, 2, and 3 is equal to the straight line of LAM, and that's a addition to that one. Okay, so now we should have the measurements of 5, 2, and 6 is equal to those by okay, so let's clear that. So now we're looking at the measurement of so with the measurement of angle 1 is congruent to the measurement of angle 5. That's because of this one. But why isn't that part of the proof though? Because that should be equal to that, so that's how we're proving those ones. Okay. That was what I did the first time. Golly. Okay, so now we were on, so this one, angle 1 is congruent to angle 5. Okay, because of the alternate angles theorem. Okay, so that means that angle 4 and 5, angle, I don't even have that one. Okay, so then now, I just did alternate interior. So it's angle 3 is congruent to angle 6, and that's going to be because of alternate interiors angle. Okay, so then is it the same thing? So then we did angle 1 and 5. We did angles 3 and 6. So then there's those two. So then so let's see if the statements of these two, and for the reasoning of okay, think about what it means when angles are congruent. So then the measurement of angle 3 is equal to the measurement of angle 6, and that's because of the definition of, okay. So then if that means that then the measurement of angle 1 is equal to the measurement of angle 5 for the same reason, Okay, so now we proved that. So then now let's see if let's prove it. Yeah. So angle 4 and 7 have nothing to do with that.
Let's use this information to solve for unknown quantities. Let's use this information to solve for unknown quantities. We can now formally state the theorem we just proved, and we can use it to find the value of x. The triangle angle sum theorem states that the sum of the measures of the three angles of a triangle is 180 degrees. So what this basic theorem says to us is that the theorem states that the sum of the measures of the interior angles, and that would be angle EDF, angle DFE, and angle FED, the sum of the measures of these angles will equal 180 degrees. So that means we can really just simply sum up the three expressions and set these sum equal to 180. So we have 3x minus 1 plus 67 minus x plus 5x minus 40, and that's equal to 180. Well, combining like terms, what does that give us? 3x minus x is 2x plus 5x is 7x. And negative 1 plus 67 is 66 minus 40 is 26. 7x plus 26 is 180. Using algebraic properties, we can then write 7x is equal to 154. And if I divide both sides of the equation by 7, I find x to be 22. Now, once I know x is 22, what I can do is I can find the measure of angle E, because that would be 67 minus 22, which is 45. I can find the measure of angle D, because I know 3 times 22 minus 1 gives us 66 minus 1, which is 65. And lastly, because I know that the measure of angle F is given by 5x minus 40, I can find the measure of angle X by taking 5 times 22 minus 40, which is 110 minus 40, and this gives us 70. And we know the answer is correct. Why? Well, when you add up the angle sum, or when we add up the angle measures, they sum to 180 degrees. 45 plus 65 plus 70, 180. Determine the angle measure of angle ACB.
Okay, so I gotta annotate this to find out. So This we know is a right angle, which is going to be 90 degrees. Okay, so let's see. So if this is 90, this angle A plus B plus C is equal to 180. Okay, I'm gonna clear all that out because I'm gonna write this in text better. If A plus B plus C is equal to 180, okay, well we know that A is equal to 90. Okay, so then that means that this is gonna be 90 plus 7x minus 20, and angle, well, let's put in B is 4x, and that is going to be added to 7x minus 20, which is equal to 180. Okay, so now what I got to do is I got to combine my like terms, which my like terms is 4x and 7x, so that creates 11x. Okay, so when I go 90 minus 20 is 70, so this is plus 70 because that's still positive, is equal to 180. Okay, so now what I got to do here is I got to subtract the 70. I got to subtract 70 from both sides. Okay, and what that would leave us left over with is 11x is equal to 180 minus 70 is 110. Okay, so there's that. That's what that, that's not a plus sign. This right there should be, so let me undo that one, because what we're left with here, and let me change the color then, is gonna be 11x is equal to 110. Okay, so now I gotta divide that. Gotta divide both sides by 11. X is equal to 10, because 110 divided by 11 is 10. Okay, so what is the measurement of angle ACB? ACB. So we're looking for this angle right here. This is the angle we're looking for, and this angle will be 7 times 10 minus 20. Okay, so 7 minus 10, that's an ugly 10. 7 times 10 is 70, minus 20 is equal to 50. So the degree is equal to 50 degrees.
Now, let's examine a theorem that is related to the triangle angle sum theorem. The third angle theorem. This says if two angles of one triangle are congruent to two angles of another triangle, then the third angles of the triangles are also congruent. Now this should make sense. It really follows if you think about it, because if you have two corresponding angles of the same measure, we have a pair of corresponding angles in each triangle. And if we know that the interior angles of a triangle sum to 180 degrees, substitution will enable us to say that these third angles must also be congruent. Well, let's prove this theorem with an interactive. We have triangles ABC and DEF. And we're given that angle A is congruent to angle D, while angle B is congruent to angle E. And what we need to show is that angle C is congruent to angle F. All right, so our first step is to state the given. And our given is that angle A is congruent to angle D and angle B is congruent to angle E. And if you do have congruent angles, you know the measures of these angles will be the same. So our definition of congruent angles says the measures of A and D will be equal, and the measures of B and E will be equal. Now, what else do we know? Well, we know that the sum of the angles, sum of the interior angles of a triangle is 180. So, by the triangle angle sum theorem, we can take the measure of angle A plus the measure of angle B plus the measure of angle C and set it equal to 180. And we can do the same for the second triangle. Take the measure of angle D as well as E as well as F, sum them up and get 180. Since we have two equations, each set equal to 180, we can go ahead and set the two sums that are equal to 180 equal to each other. And once we have those sums set equal to each other, look very carefully at step 2. Because while step 2 says the measure of angle A is equal to the measure of angle D, we can interpret this to mean we could replace the measure of angle A with the measure of angle D. So if I take a look at step 5, on the left side, I will replace the measure of angle A with the measure of angle D. Also, I will replace the measure of angle B with the measure of angle E, again, because of what I see in the second step. So again, on step 5, on the left side, I'll replace the measure of angle B with the measure of angle E. And this gives me, using substitution, that the measure of angle D plus the measure of angle E plus the measure of angle C is equal to the measure of angle D plus the measure of angle E plus the measure of angle F. That's a lot to say. So now I'm going to see if I can solve this or the equation so that I can go ahead and isolate on the measure of angle C and the measures of angles F. I will subtract from both sides of the equation the measure of angle D and the measure of angle E. And this gives me that the measure of angle C is equal to the measure of angle F, which tells me that angle C is congruent to angle F by the definition of congruency. This tells me that the third angles in the triangle will be congruent. You've done a really good job answering the question, how are the interior and exterior angles of a triangle related? Now, we've explored the sum of the interior angle measures of a triangle. Now we're going to define and explore the relationship between exterior and interior angles of a triangle. Triangles consist of 3 interior angles, as well as angles called exterior angles. Now, we've looked at interior angles and the sum of their measures before. Let's identify them from this triangle. We have angle BAC. Let's see if we can identify that. And angle ABC. And lastly, angle BCA. Now, as I move over to take a look at the exterior angles, I'm going to extend the sides of this triangle. I'm going to extend this side and label a point on the extension Z. Then I'm going to turn around and extend this side, label a point X. And I'm going to extend this side and label a point Y. And I notice 3 different exterior angles. Here's one. I have angle ZAB. I have a second one right here, angle XBC. And lastly, this exterior angle, which is angle BCY. But I just as easily could have done what? I just as easily could have turned around and created the extensions differently. So we can come up with a whole bunch of different exterior angles from 3 different extensions. Now, what does that mean? Well, I could have turned around and extended this side, labeling a point on the extension Z. Then I could have gone to line segment BC, extended it in both directions, putting an X on one side of the triangle and on the other side of the triangle, placing a Y. And as I go ahead and label, I can create an exterior angle here, which would be angle ZAC. I can find an exterior angle here, which is angle ABX. And lastly, I see an exterior angle right here, don't I? Angle ACY. Well, take a look at these 2 figures in front of us. Exterior angles are created by extending only one side of a triangle, but should be supplementary to the interior angle. Well, what this means is that we have two angles that are supplementary, meaning that their measures have a sum of 180. Take a look at angle TAC and angle BAC. If I take a look at the measure of angle BAC and add it to the measure of angle CAT, I end up with 180. In my non-example, though, what do I notice? Well, I notice that I don't have exterior angles. Why? Well, it's because these two angles that we have are not supplementary. Determine the statements that are true about the angles of triangle EFG.
XFG is an interior angle of this one. That's not true. That's an exterior angle. EFG is an interior angle. EFG is an interior angle. FEZ is an exterior angle. That is correct because FEZ is out here. YGE is an exterior angle, so that's true. EGF and FGY are supplementary angles, that's true. And let's see, FEG and FGE are supplement. FEG and FGE, that is not true.
Exterior angles are angles created by extending the sides of the triangle. Now let's look at a theorem involving exterior angles.
YGE. Okay, so that was that one.
Exterior angles of a triangle are more than just supplementary to their adjacent interior angle. The exterior angles theorem tells us that the measure of each exterior angle of a triangle equals the sum of the measures of the remote interior angles. Now, the remote interior angles are each of the two non-adjacent interior angles that correspond to each exterior angle of a triangle. In other words, in this particular diagram, the exterior angle is angle ABD, while the two remote interior angles would be angle BDC and angle BCB. Well, let's go ahead and walk through an informal proof of this. And the first thing I'm going to do is just label angles for simplicity 1, 2, 3, and 4. Now we know that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. And we know this because an exterior angle is supplementary to its adjacent interior angle. And we also know that the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 is equal to 180 degrees. And this is because they are all interior angles of a triangle. So we can substitute. And if we do, we have the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4. And using the algebraic property of subtraction, we can subtract the measure of angle 2 from each side of this equality. And what does this leave us? Well, this leaves us with the measure of angle 1 equaling the measure of angle 3
Let's cancel out.
plus the measure of angle 4, which is exactly what we were looking for, which was the measure of the exterior angles equal to the sum of the measures of the remote interior angles. Let's look at an application of this. And in the application, what we want to do is find the measure of angle XFE. And we're going to use our exterior angles theorem because we know that our exterior angle is equal to the sum of the measure of the two remote interior angles. So let's write this out. What do we have? Well, we have the measure of angle XFE, the exterior angle, equaling the measure of angle FEG.
This one plus this
plus
one equals this one.
The measure of angle FGE. Now let's substitute in their expressions. So what does this give us? Well, this gives us 3k plus 30 is equal to 95 minus k plus 2k minus 5.
95 minus that is 90.
And if
Negative
we
k
combine
plus 2k
terms, we
is
end up
k
with 3k plus 30
90.
is equal to 95 minus 5 is 90. Negative k plus 2k is plus k. Well, let's go ahead and solve. Let's subtract the k from both sides of the equation, leaving 2k plus 30. And that's equal to 90. Subtract the 30 from both sides of the equation. That leaves 2k is equal to 60.
Minus k over
we
here.
find k is equal to 30.
Okay.
And once we know k is equal to 30, we can find the measure of angle XFE.
3 times
because
30.
we know that the measure of angle XFE, well, that would be equal
90
to
plus 30 is
3 times 30 plus 30. And that's 120.
that one was easy.
Complete the steps to determine the measure of the exterior angle.
Angle XBC is equal to 3p minus 6, which equals the measurement of BAC, which is p plus 4, and the measurement of BCA is 84 degrees. So when I combine this equals 88. P stays the same. So now I'm going to go ahead and take this p, it's a positive p, and subtract it from 3. So I'm left with 2p minus 6, bring the 6 over from 88. So this is a negative 6, so I got to add 6 to both sides, which brings this. So now right here, what I have to do is I have to divide this by 2. 94 divided by 2 is 47 degrees, because that's half of 94.
Solve for p, and then substitute this value in for the expression representing the measure of angle XBC.
Hold on a second, because this is p equals 47. Finish reading it out. Measurement of XBC, which is 3 times 47 minus 6. So 3 times 47, that's 21. Carry the 2. 3 times 4 is 12, 13, 14. This is 141 minus 6, which equals 135. Okay, so let's try that again right here. Okay, follow the directions. I would make a lot of mistakes, not just thinking and looking at what it's asking me.
The exterior angle inequality theorem. This says the measure of an exterior angle of a triangle is greater than the measure of either of the two non-adjacent interior angles. Look at this diagram. Here's our exterior angle. And we know that the measure of angle 1 is going to be equal to the measure of angle 3 plus the measure of angle 4. Well, what does this mean? Well, it should follow that the measure of angle 1 is going to be greater than either the measure of angle 3 or the measure of angle 4. Either one. Because we know the measure of angle 1 is equal to the measure of angle 3 plus the measure of angle 4. The sum of the two remote interior angles. So that means we can write that the measure of angle 1 is going to be greater than the measure of angle 3. And the measure of angle 1 is also going to be greater than the measure of angle 4.
Okay. Greater than, and M1 is greater than the measure of angle 4. Okay.
Use the drop-down menus to complete the statements.
Analyze the diagram to complete the statements. And the measurement of M, X, N is blank. The measurement of Y, Z, X. That's going to be greater than. Okay, just by looking, this angle is a lot wider than this angle right here. The line, the measurement of LZX, so this angle is blank. This angle is CYX plus YXZ. So this is equal to, because this angle should measure out to be both of these, because this and this added together. So the measurement of MYL is blank 180 degrees minus the measurement of ZYX. Let's see, the measurement of this one is equal to 180 minus ZYX. Yeah, that should be right.
The relationships between the interior and exterior angles of a triangle can be useful in finding unknown angle measures.
There it is, guys. That's the lesson on instruction for our unit triangles. The first topic is triangle angle theorems. Okay, so obviously I'm gonna need a little bit more work on the proofing side of this, so we're gonna have to figure that out. We'll figure it out together. I'll be back in a little bit with the assignment portion of this, and I'll see you guys soon.